So, on Friday we were solving equations with the variable and the exponent, remember? So we had to get the bases the same, and then we could set the exponents equal to each other. Today we're solving equations where the variable's in the base. So this actually looks very similar to things we've done before. Okay, so step 1, we want to get the exponent by itself. This should sound familiar from unit 6, 5. We multiply both sides by the... So after we get the exponent by itself, we're going to multiply both sides by the reciprocal power. So we're going to raise it to the reciprocal power to cancel out those exponents, and then we'll be able to solve for x. Okay? So example 1. We have x to the 1/2 equals 3. So in order to cancel out that 1/2, I need to raise both sides to the second power. Because when I raise a power to a power, what do I do with those exponents? Do I add them or multiply them? You multiply them. So 1/2 times 2 turns into just a 1, right? So they cancel out. So this is now x equals 3 to the second power, which is 9. Not too bad, right? Okay, so let's look at number 2. X to the 3/2 equals 8. So we need to get rid of that 3/2 exponent. So we're going to raise both sides to the reciprocal power, which is 2/3. Okay. So now these guys cancel, so we have just x by itself. Equals 8 to the 2/3. Now let's rewrite this in a way that we can actually simplify it as much as possible. This 3 is the index, right? So it becomes the cube root of 8, all of that raised to the second power. Okay, the denominator is the index, the numerator is the exponent. Okay. What is the cube root of 8? 2. And what is 2 squared? 4. So our answer is x equals 4. Not too bad, right? Okay. So what happens if I have something like example 3? Is my exponent by itself yet?
No.
No. So what should I do before I can do anything else? Divide by 4. So we need to get rid of that 4. That gives me x to the 3/4 equals 108 divided by 4, 27. Okay, and then to get rid of that exponent, what do I do? Raise the whole thing to the 4/3, so to the reciprocal. Yeah. So these cancel, so we get x equals. We can rewrite this as cube root of 27 raised to the 4th power. Okay, cube root of 27 is 3, and 3 to the 4th power, 81. So x equals 81. Still feel good? Example 4. Okay, guys. What do I do first here?
Divide by 2.
Divide by 2. Good. So we get x to the 2/3 equals 25. And then we want to get rid of this exponent of 2/3, so I raise the whole thing to the reciprocal, which is 3/2. So all of these guys cancel. So I get x equals, how can I rewrite 25 to the 3/2? Square root 25. All of that raised to the 3rd power. Now the index 2 is actually a square root, but we don't have to write it, right? Okay. So it's just like when we have an exponent of 1. It's there, but we don't have to write it. So what is the square root of 25? 5. And 5 to the 3rd power is? 125. So we get x equals 125. Okay, so what we have to do first here is we need to get the exponent by itself. So I need to first get rid of that minus 5 by doing what? Adding 5. So let's add 5. So that's going to give me x minus 2 to the 5 halves equals 27 plus 5, 32. Okay, now I have the exponent by itself, right? So I need to raise the whole thing to what power? 2 over 5. So I raise the whole thing to the 2 over 5th power. So everything there cancels. So on the left-hand side, we have x minus 2 equals, and we can rewrite this as 5th root of 32, all of that to the 2nd power. And anybody have any ideas what the 5th root of 32 is? It is 2. So this is x minus 2 equals 2 squared. So we have x minus 2 equals 4. And then to solve for x, add 2 to both sides. Which, so we get x equals 6. Okay, example 6. Okay. So we have 1/5 times x plus 2 to the 3 seconds equals 25. So here's my exponent right here, x plus 2 to the 3 over 2. So what do I need to do to get that exponent by itself? Multiply both sides by 5. So these guys are going to cancel. I will be left with x plus 2 to the 3 halves equals 25 times 5, 125. Okay, so my exponent is by itself now. So I need to raise the whole thing to the 2/3. Okay. So that is all going to cancel. So I get x plus 2 equals, and we can rewrite this as cube root of 125. All of that squared. Cube root of 125? 5. So we get x plus 2 equals 5 squared. So x plus 2 equals 25. Subtract 2 from both sides, and x equals 23. Okay, last two. Okay, now example 7 is kind of taking 5 and 6 and putting them together. So what does it look like I'm going to need to do first here? Subtract 5, good. So that gives me negative 2 times x minus 7 to the 1/3 equals 16. Very good. So then we divide both sides by negative 2. That gives me x minus 7 to the 1/3 equals negative 8. And then we raise both sides to the reciprocal. What's the reciprocal of 1/3? 3. 3 over 1, or just 3. So this is x minus 7 equals negative 8 to the 3rd power. What's that going to give me? Negative 512. We're not taking the cube root, we're just cubing it. So it's just all multiplying. Okay, so we add 7 to both sides. So x equals negative 505. Okay, so on this one, because we're just raising it to the 3rd power, we're not taking a root at all. So all we do is multiply negative 8 times negative 8 times negative 8. Okay, last one. 3x plus 17 to the 4/3 equals 16. Question, is my exponent by itself? Yeah, it is, because all of this is in parentheses, right? So we can raise the whole thing to the 3 over 4. So those exponents are all going to cancel. So we get 3x plus 17 equals, let's rewrite this. My index is 4, so I'm taking the 4th root of 16 and then raising that to the 3rd power. So this is 3x plus 17 equals, what's the 4th root of 16? 2 to the 3rd. So 3x plus 17 equals 2 to the 3rd, 8. And then this is a two-step equation. We subtract 17 from both sides. So 3x equals -9. And then we divide both sides by 3. So x equals -3. What do you think? Not too bad, right?
Simple.